Assalamu alaikum. Welcome to our class of Aircraft Instrumentation and Avionics, SEMT 4253, Section 11. Today I'm going to present our group project. I'm from Group 3. My name is Kaushik Chowdhury with my group members Azrul, Cheok, Zacky and Lee. So our topic of the group project is CNS technology, communication, navigation and surveillance system of the aircraft. So okay, demonstration, evaluation and experiment of CNS technology. So demonstration, CNS communication, navigation and surveillance technology are fundamental to aviation. All depend on the ability and suitable frequency spectrum. Various CNS and CNS spectrum. Without CNS and spectrum, aviation travel would not be possible. So the communication, air traffic controller and pilot, they must communicate air to ground and ground to ground. These two communications are important. For navigation, there are four types of navigations. Number one is VOR, which is very high frequency omnidirection range. Number two is DME, distance measuring equipment. Number three is NDB and ILS system. For surveillance, there are two types of surveillance. So one is the cooperative surveillance, the other is the non-cooperative surveillance. And for surveillance, two radars are used, the primary radar and the secondary radar. So evaluation, how these systems are evaluated. Now communication systems are critical in aeronautics as they enable pilots, traffic controller and ground crew to exchange important information necessary for safe and efficient flight. So in the evaluation, the factors that affect are bandwidth, frequency range, modulation techniques. These can impact on the performance of the communication system. Factors such as redundancy, fault tolerance and system testing are key to ensuring the reliability of the communication system. For navigation, navigation system is crucial to ensure their accuracy, reliability and effectiveness in guiding aircraft at different scenarios. The accuracy of the navigation system refers to its ability to provide precise and reliable guidance to aircraft. Now, navigation system's ability to maintain the weather conditions are critical for its effectiveness, like fog, rain, and snow, can affect the system's ability to provide accurate guidance to aircraft. Okay. Now, it refers to a system ability to maintain its accuracy performance level under varying conditions, including environmental factor. And the accuracy of the navigation system refers to the ability to provide precise, reliable guidance to aircraft. It is usually measured in terms of system error rate, which is difference between the accurate position of the aircraft and the position indicated by the navigation system. Surveillance. About the evaluation of surveillance. Surveillance system is essential to ensure their accuracy, reliability, and effectiveness in tracking aircraft in different weather conditions. The accuracy of surveillance system refers to its ability to correctly identify and track aircraft. It is usually measured in terms of system error rate, which is the percentage of incorrect identification or missed aircraft. Reliability is the consistency of the surveillance system performance over time. It refers to system's ability to maintain its accuracy and performance level under varying condition. Okay, so the weather condition is very important for surveillance. Also, the weather condition like fog, rain, and snow affect the system's ability to detect and track aircraft accurately. And last but not the least is the experiment. For experiment, some examples of the communication system that are being tested in aviation, including digital voice communication system, automatic dependent surveillance broadcast, controller pilot data link communication, and data link communications. Now for navigation, the new systems that are being tested or experimented are for navigation, global navigation satellite systems, automatic dependent surveillance broadcast, that is ADSB, enhanced flight vision system, and synthetic vision system. Synthetic SVS provides pilot with a 3D view of their surroundings using computer generated imagery, which can improve situation awareness and reduce the risk of accidents. Next is the surveillance experiment that have been carried out. Some examples of experiments that have been tested in aviation industry is the automated dependent surveillance broadcast, is a technology that uses satellite-based navigation to provide more accurate and real-time information on the location and movement of the aircraft. Then the ADSB, and then primary surveillance radar, which is the PSR, is a radar system that uses radio waves to detect presence and location of the aircraft in the airspace, and then the secondary radar. So thank you very much. I would like to call upon my next teammate to present.
Okay, in this part, we'll be talking about the surveillance and navigation data in the cockpit. So it actually consists of a two display, which is the first one, primary flight display, and the second one, multi-function display. So these displays provide pilot with real-time information on aircraft location, altitude, speed, and navigation data. So in the primary flight display, it is the source of data for pilot, and there will be data such as the flight data, speed indicator, attitude indicator, altimeter, and direction indicator. While in the multifunction display, it will show navigation data and meteorological data from server systems, and also data such as route plan, weather information, and aircraft traffic. So let's go to primary flight display. So basically there will be 8 of the primary one. The first one is the navigation frequency window, which will display the active and standby frequency for dual VOR and ILS receiver. And the second one is the navigation status bar, which display flight plan information such as next waypoint, distance to the next waypoint, and the current track when flying a route created using the flight planner. And the third one is the communication frequency window, which display active and standby frequency for dual VHF transceivers. And the fourth one, we'll be talking about the altimeter, which display the barometric altitude in feet on a moving tab, indicates that the approximate altitude that will be reached in 6 seconds given the current vertical speed. And the fifth one, we'll be talking about the airspeed indicator, which display the aircraft's current airspeed on moving tab. And the sixth one is the attitude indicator. The attitude indicator will display the aircraft attitude, and the attitude indicator indicates degree of pitch and degrees of roll. And the seventh one is the horizontal situation indicator. The horizontal situation indicator has as eye display a rotating compass card with the aircraft's current heading at the top. And last but not least, which is the nearest airport dashboard, is to quickly navigate to one of the airport closest to your position. So next, we'll be talking about the multi-function display. The GPS multi-function displays combine the engine information with a full-featured GPS and moving map display. So the first one, the engine indication system, which display on the left side of the MFD, and which will include with the gauge, the bar graph, and numeric reads out of engine parameters. And for the second one is the MFD page groups. The GPS or the navigation information that appears on the MFD is presented on pages, and you can only view one page at a time. And some pages are organized in groups of related pages called page groups. So you have to think like the page group as chapter in a book, and the pages as the page within each chapter. There are three page groups model, which are the map page group, the waypoint page group, and the nearest page group. Okay.
Protocol and architecture are related but distinct concepts in the field of computer networking and information technology. In the context of CNS, communications, navigations, and surveillance, the architecture refers to the design and organizations of this entire system used in the aviation industry. A protocol, on the other hand, refers to a set of rules and standards that governs the communications between devices in a network. It defines the format of the data being transmitted. In the context of CNS, protocols are used to ensure the seamless and reliable exchange of information between aircraft, air traffic control centers, and ground-based facilities. There are some common architecture and protocols used for CNS. For architecture, Automatic Dependent Surveillance Broadcast (ADSB) system, Global Navigation Satellite System (GNSS), and Air Traffic Management (ATM) system are some commonly used architecture in CNS. ADSB system is a surveillance system used in aviation to enhance air traffic management and improve flight safety. It uses GPS technology to determine the precise locations of an aircraft and then broadcast that information to air traffic control and other aircraft. It facilitates movements of aircraft, allowing them to move efficiently and reduce the risk of collision. Global Navigation Satellite System (GNSS) is a system of satellites that provide precise positioning and timing information to users on the ground, in the air, and at the sea. It is used to provide precise navigation information to aircraft, allowing them to fly more effectively. Air Traffic Management (ATM) is a system used to manage and control air traffic in order to ensure the safe and efficient flow of aircraft. It provides air traffic controllers with real-time information on the locations and movements of aircraft. While for protocols, Controller-Pilot Data Link Communications (CPDLC) and Automatic Terminal Information Service (ATIS) are two common use protocols. CPDLC facilitates communications between air traffic controllers and pilots. It uses text messages that can be transmitted through a data link, rather than relying on the traditional method, which is traditional voice communications via radio. Moreover, ATIS is a system used in air traffic management to provide continuous information to pilots and air traffic controllers about the current conditions at the airport, such as the current weather, runway conditions, and so on. Both protocols and architectures are important for ensuring the effective and efficient operations of the CNS technology in the aviation industry.
Okay, we move on to the next chapter, which is communication system and technologies. So there are some important components in aircraft communication system, which is flight deck communication system, cockpit voice or flight data recorder, radio altimeter, and the transponder. Next, they have two communication system that usually used in radio equipment in aircraft, which is the first one is HF communication, which HF is high frequency, and the VHF communication is very high frequency. So the difference between these two communication system is the frequency range, which is for HF communication system, they will be 3 to 30 megahertz, while the VHF is between 30 to 300 megahertz. So HF signals can travel thousands of miles through the ionosphere, while VHF signals are limited to line of sight communication. So in terms of the quality, VHF provides better audio quality compared to HF communication system, while for the interference, VHF is more susceptible to interference compared to HF, and VHF signals can be affected by terrain, buildings, and other obstacles that may cause interference. So for the users, HF is used for long-range communication and is often used by aircraft in remote areas where VHF signals are not available. And for the VHF is primarily used for air traffic control and flight communication between aircraft and air traffic control centers. Next communication system is satellite communication system. So from the figure you can see they have three communication, which is the components of the system, satellites itself, which is the overview of communication satellites and their role in aviation. So next component is ground station. It is importance of ground station in satellite communication system. Antennas, types of antenna used in aviation for satellite communication. Transceiver, explanation of the transceiver and their role in aviation. So the function of the system for the data transmission, it is overview of data transmission through satellite communication system. Next, explanation of voice communication through satellite communication system. Their flight information and weather information also. So the advantages of satellite communication system in aviation is, the first one is reliability, and the second one is the global coverage. So that's all for me. Thank you.
Hi, I'm Muhammad Zacky Alghifary. I'm here to talk about surveillance system technologies. Air traffic control, or short for ATC, is a system technology used for surveillance in aviation, and it is responsible to safely direct aircraft thanks to surveillance devices that identify aircraft. It gives precise data to the ATC system, and then it is a service that controls air traffic, facilitates and maintains an orderly flow of traffic, avoids aircraft-to-aircraft collisions, and collisions between aircraft and ground obstacles. Airspace based on different divisions of control. The first one is ground aerodrome control tower, and then second, terminal approach, aircraft landing and taking off. The controls who are part of this division work in the terminal approach control center, and then lastly, en route aircraft at a medium to high altitude. En route controllers work in an area control center, and below is pictures of air traffic control tower in Mumbai International Airport, and then Singapore Air Traffic Control Center, and then Canada ATC Area Control Center. As for classification, it is based on dependency. The first one is dependent surveillance, and then the second one is independent surveillance. Important parameters of sensors are two, which is position accuracy and refresh rate. Factors which may impact the parameters, especially position accuracy, are type of sensor, technology within the sensor, and then relative position of the aircraft to the sensor. And then the factor which may impact refresh rate is human error and system failure or bugs, which may deter the refresh rate of the sensors. And then here's the surveillance technologies. The first one is primary surveillance radar, which is PSR, and then second one, secondary surveillance radar, SSR, multilateration, MLAT, and lastly, automatic dependent surveillance broadcast, ADS-B. Here's the benefits and risks and challenges for surveillance system technologies. So the benefits are better situational awareness for the controller. Aircraft with radio communication failure can be identified and their flight path monitored, and then reduced separation standard, reduced frequency congestion, and then availability of support tools, and then reduced controller workload. And for risks and challenges, there are many, such as sensor failure, transponder failure, ATS system failure, incorrect position calculation, and data processing delays. So that's all the presentation from our group. Thank you so much for your attention.